Well, hello there. We are now going to do a full review for the final for MA 1310, which is College Mathematics 2 at ITT Tech. I hope you will enjoy this, or at least find it useful. Okay, let's just talk about what we're going to cover tonight, all right? I am going to cover graphing of sine and cosines. That's basically our Unit 1 and Unit 2 stuff. I'm going to calculate sine and cosines for given angles. I'm only going to give you one logarithm problem. And the reason for that is that logs are fairly well covered by other videos I have on my YouTube channel. Basically, they're ones I've liked, and I don't think I could do better than those, so we'll just leave those alone. I will finish up with some combinatorics. That was just kind of the last stuff we did. The law of sines and cosines I'm not going to cover because I covered them in another video that I've already, I think I even showed that one in class. But if you need brush-ups on the law of sine and cosines, please see that other video. Okay? Okay, take a look at this guy. This is a template for understanding the sine function. We can fill in anything we want for the numbers, positions A, B, and C, any whole numbers we want. Or actually, any real numbers we want can go there. Alright, now what do all these numbers mean? What is the amplitude? Well, you might recall, if you say it's A, you're almost right. Amplitude is the absolute value of A. Okay, because amplitude can't be negative. What's the period? Well, the period makes you do a little bit of a calculation. Whether it's sine or cosine, you're going to take 2 pi and divide it by b. 2 pi divided by b, and that will give you the period of this function. And that mysterious phase shift, that will be c over b. Notice that in the template we have a minus sign here. If that were a plus sign, then this would be negative c over b. Okay, you'll get that tricky question every once in a while. Okay, here's a live problem. Now this is cosine. I just gave you the template for the sine, but they work exactly the same way. What do you think the amplitude is? If you said -2, of course you're wrong, because amplitude can't be negative. It'd be the absolute value of -2, which is 2. What is the period of this function? Well, you have to do a calculation for that. It's 2 pi over 3, as I just said on the previous one. 2 pi over 3, and can't be simplified at this point. What is the phase shift? In this case, it would be 6 divided by 3. Which is 2. Simple, right? Now when you take the final, you may get pictures of graphs like this, and it may ask you to come up with the equation of the function that you can see in the graph. Okay, that's not very hard. You just have to be kind of a Sherlock Holmes on it and just pick up some pointers here and there. Now just looking at this, you can kind of notice that it goes through the origin, doesn't it? Well, yes, so it goes through 0, 0. One function you know is like that. It's the sine function, so maybe this is one type of sine function. You'll also can probably notice the amplitude line never goes any higher than 1 or any lower than -1. So it probably has an amplitude of 1. Okay. As for the period, well, let's see. Let's say it's starting a period here. It's beginning its second period way out here, a little beyond 6. That kind of tells us that the period is near 2 pi, or let's say it's just 2 pi. Putting those three facts together, you probably recognize this as the standard sine curve. Y equals sine x. The amplitude is 1, A is 1, B is 1, C is 0 because there is no phase shift. So this is an example of a graph that I didn't play any games with. So it's just a standard vanilla. Alright, now this function I've done some things to. First of all, notice this function seems to have a minimum at x equals 0. That's kind of different from any function you know offhand, but no, first of all, it's probably a cosine. Cosine has a maximum at x equals 0, but there's probably a negative sign involved to flip it around. That makes sense. And let's look at its amplitude. It seems to go all the way up to 2, doesn't it? So it has an amplitude of 2. Now this is kind of tricky. What do you think the period is? Well, let's see. It's going uphill here. It begins to repeat itself right around here. That's a little more than 3. So this one probably has a period near pi or at pi. Now let's put all that together. We know there was a minus sign involved because it's the cosine and it's been flipped. And we know it has an amplitude of 2. We really don't know what b is yet, but we know we want the period to be pi. To find b, we want the period to be equal to pi. So let's use the formula that we've already learned tonight. Period equals 2 pi divided by b. We want the period to be pi. So all we have to do is use some common algebra, flip this around, cancel the pi's, and what do we get? B equals 2. So now we got the entire answer. Y equals negative 2 cosine 2x. Okay? So there's your A, there's your amplitude, and there's your B, and there is no C because there's no phase shift. Okay? You'll probably get one problem like this. Given a point 3, 4 on the terminal side of an angle, find the cosine of A. So we want to find the cosine of this angle here, given that this point here is the point 3, 4. All right, we'll think about that. Now, what does that mean? First of all, if this is the point 3, 4, how long is this side here? Well, if you said 3, you're correct. And if this is a point 3, 4, how long is this side here? If you said 4, you're correct. Now getting the long side, which is the hypotenuse, what would we have to do to find the long side? Well, you might remember the Scarecrow in the Wizard of Oz. He gave us the Pythagorean theorem. He stated it wrong, but I'll state it for you correctly. It's that. So we got to take 3 squared plus 4 squared, add it together, take the square root, and we'll get C. We'll get the long side of this right triangle. Doing that, we find that the long side is 5. Okay, so we know all sides. How does that help me find the cosine of A? You might recall the rule that to find cosine of A, it's the adjacent side divided by the hypotenuse. Adjacent divided by the hypotenuse. In this case, that's 3 divided by 5. Now, what if I asked you a much different question? What if I asked you the sine of A? Do you remember the rule for that? Well, that would be the opposite side divided by the hypotenuse. That would be 4 over 5. What if I asked you the tan of A? Well, that's opposite divided by adjacent, so that would be 4 over 3. I didn't ask you any of that, but I just thought I'd throw that in. So, okay, let's go on. All right, let's go into a different direction this time. Let's do an interest problem. How long will it take for $100 to double to $200 at 6% interest compounded twice a year? Well, everybody asks me, when will I ever use this math? Well, here's something you can use because it's a banking problem, and you're all going to take loans, and you should know how this works. This is the formula you're going to use, where A represents the amount that you're going to get, P is your principal, R is your interest, N is the number of times per year you're compounding interest, and T is the time you got it invested. Okay. In this particular problem, these are the values we're going to use. The amount we want is $200, the principal is $100, the interest rate is 0.06, you always write that as a decimal. You're compounding twice a year, and T is what we're looking for. Let's plug all those numbers in. And this is what you would get when you plugged all the numbers in. Now, how are you going to solve this? Notice that your variable is in the exponent. That makes this an exponential problem, and you solve exponential equations, and you solve exponential equations using logarithms. So let's take, well, before we do anything, let's simplify this. That simplified very nicely, didn't it? Now what I did is I divided both sides by 100, so this 100 went away and this turned into 2. I took 0.06 divided by 2, which is 0.03, added it to the 1, 1.03, and you still have your exponent. Okay, at this point, let's take common log of both sides. Now let me explain this one too. So we took the common log of 2, and I took the common log of all of this thing, but I also brought the exponent, which was here, and I brought it down to the front. I'm allowed to do that because I'm using the power rule for logarithms. Okay. Now t is no longer in an exponent. It's this down here with the rest of the equation, which means you can solve for it. You'd get that once you solve for t. And now plug that into your calculator. And look at that. It would take you almost 12 years to double $100 to $200 at 6% interest compounded twice a year. That's interesting. I didn't think it would be that long. Okay, everyone. Now let's talk about combinatorics, the science of counting how many ways you can do things. You will see this symbol on your test, and you will see this symbol on your test. This represents the number of ways you can pick R things out of N without regard to order, and this is the way you can pick R things out of N with regard to order. And I'll give you an example of that. This is the formula for R choose N, which is how you pronounce that. N factorial over R factorial times N minus R factorial. This is the formula for the permutation one, where you do take order into account. N factorial over N minus R factorial. The only difference, you don't have that extra R factorial right there. Okay, let's look at an example. How many ways can you pick 3 things out of 6? Say you got 6 cars and you only have a 3-car garage. How many different ways can you pick which cars get to go into the garage? Is it the Ford, the Chevy, and the Volkswagen, for example? Here you don't really care about order. Now to figure that out, you would use this formula. 6 choose 3. And it would be 6 factorial over 3 factorial times 3 factorial. That's not too bad to figure out by hand. Writing it all out, you got 6 factorial here, all the factors down to 1. Here's your 3 factorial, your 3 factorial. Notice that the 3 times 2 times 1 cancels with this 3 times 2 times 1. That just leaves you this. 3 times 2 is 6, of course. That cancels this 6. You're basically left with 5 times 4 over 1, which is 20. So there are 20 different combinations of 3 groups of cars that you can put in your garage out of 6 cars. Okay. Now let's take order into account and go the other way. How many ways can you pick 3 things out of 6 and line them up in a row? Okay, using our examples before, you still got 6 cars, you got a 3-car garage, but the parking places in your garage are now numbered 1, 2, and 3. How many ways can you put cars into those 3 places, 1, 2, and 3? So if you pick the Ford, the Chevy, and the Volkswagen, well, you can put the Ford in the first place, the Chevy in the second place, the Volkswagen in the third, or you could put the Volkswagen in the first place, and so on. So as you can see, there'd be more combinations with this one. This is what we're looking for. 6 choose 3 as a permutation, which means we're taking order into account. That's simply 6 factorial over 3 factorial, which is this. 6 all the way down to 1, 3 times 2 times 1. Cancel all of this. Your answer is going to be 6 times 5 times 4, which is 120. As you can see, this is much bigger than that number. Okay, so if you've got a good calculator, it'll calculate these symbols for you. Even if you've got a cheapo calculator or no calculator at all, the ones you're going to get can be done by hand. Okay? And that's about all I wanted to show you. I will accept any email questions you have. Please ask me questions in the classroom, of course. And I wish you all good luck on the final. And that is the end.